In this video we're going to look at how to solve SUVAT equation exam questions. Looking at the first one in the pack that I've sent you. A digital camera was used to obtain a sequence of images of a tennis ball being struck by a tennis racket. The camera was set to take an image every 5.0 milliseconds. The successive positions of the racket and ball are shown in the diagram below. We've got a distance marked on there. We had a time in the question. And the time, it says, is between images, so each of those gaps is 5.0 milliseconds. A. The ball has a horizontal velocity of 0, information, at A, and reaches a constant horizontal velocity at D as it leaves the racket. The ball travels a horizontal distance of 0.68 meters between D and G. Part 1. Show that the horizontal velocity of the ball between positions D and G in the diagram is about 45 meters per second. It is a show that question, so the answer that we need at the end is 45 meters per second. That means we don't use 45 meters per second. At the end, our answer should be approximately equal to 45 meters per second. That's what we're aiming for. So, what we're going to do, we know that each of these gaps is 5 milliseconds, and there are 1, 2, 3 gaps. So our total time, our change in time, is 3 times by 5.0 milliseconds, which is 15.0 milliseconds. Now for SUVAT we're going to need to convert that into seconds. So the easiest way, milliseconds to seconds, 10 to the minus 3 seconds. Now it wants the speed, show that the horizontal velocity, if it's a constant velocity, it's not accelerating, it's going from 0 up to about 45 in 15 milliseconds. So we want our change in distance divided by our change in time. The change in distance, 0.68 meters. The change in time, 15 times 10 to the minus 3 seconds. So I type that in my calculator. 0.68 divided by 15 10 to the minus 3 equals 45.3 recurring, which is approximately equal to 45 meters per second. Solved. Part 2. Calculate the horizontal acceleration of the ball between A and D. Now, looking at this bit of the question where it starts from 0 and gets to the velocity that we just worked out, 45.3 meters per second. So, acceleration is change in velocity divided by change in time. Our change in velocity is from 0 to 45.3 meters per second, divided by our change in time. It is another 1, 2, 3 gaps, so our change in time is the same, it's 15 milliseconds. So I'll type that in my calculator. 45.3 was already on the screen, divided by 15 times 10 to the minus 3 gives us 3022 meters per second squared. Part B. At D, the ball was projected horizontally from the height of 2.3 meters above level ground. Show that the ball would fall to the ground in about 0.7 seconds. It's a show that question. Our answer needs to end up at 0.7. So at the end our answer should be approximately 0.7 seconds. So we need to get to there. It's a SUVAT question, but we are working vertically. We want the time it takes for that ball to fall to the floor. So vertically, we've got S, U, V, A, T. The distance is the height above the ground, 2.3 metres. The initial velocity, vertically, is 0. It starts from 0. The final velocity we have no information on, so we're going to use the no v equation. I could spell equation right. The acceleration is the acceleration due to gravity, 9.81 metres per second squared. The time is our unknown, what we're trying to find out. So we're going to say our no v equation from the datasheet. Get the datasheet, and then no v equation, s equals ut plus a half at squared. S equals ut plus a half at squared. Because u is 0, that term goes to 0. So I've got 2.3 metres equals a half times by 9.81 times by t squared are unknown. Okay, so now I simplify. I can do half times 9.81 to get 2.3 equals 4.905 t squared. So t squared is 2.3 divided by 4.905. We divide by 4.905 on both sides. So 2.3 divided by 4.905 is 0.4689, but that's t squared, so I square root that and get 0.6847 dot 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 dot, which to one decimal place rounds to 0.7. B part 2. Calculate the horizontal distance that the ball will travel after it leaves the racket before hitting the ground. Assume that only gravity acts on the ball as it falls. The only gravity bit should imply to us no air resistance. So this time it means we're working horizontally. But we follow the same method. We say S, U, V, A, T. Horizontal distance is what we're trying to find out. That is our unknown. U, the initial velocity, we calculated in the first question, 45.3 metres per second. V, the final velocity, we have no information on, so we use the no v equation. A, the acceleration, because there is no air resistance, only gravity, horizontally there is no deceleration. And the time we worked out in the previous question, 0.69 seconds to two significant figures. So the no v equation that we used last time, s equals ut plus a half at squared. But because a is 0, that term is 0, we're left with s equals ut. U, 45.3 times by t, 0.69, gives us 45.3 times by 0.69 equals 31.3 metres to three significant figures. Part 3. Explain why in practice the ball will not travel this far before hitting the ground. We already thought about it. It's because there is no air resistance. So we needed to say something like, for the first mark, the ball will actually have air resistance. So, for the second mark, there will actually be horizontal deceleration. Second mark. The end.